This is less than 11 in algebra, and it's called number patterns. Number patterns are also sometimes called sequences, and they have a strong association with algebra because they actually follow a particular rule. And what I want to do at the moment in this lesson is look at the different types of rules you can get when you have number patterns. The first rule, or the first type of number pattern, is this one here where we've got 2, 6, 10, 14 and 18. Now you might notice there's a constant amount between each of the successive terms. You see there's a 4 there, a 4, 4, 4, 4. Okay, so each term is increasing by 4. This 4 is called a common difference. Now the common difference could be negative, which means the pattern could go down, alright, or the common difference could be positive, which means the pattern goes up. Second type of number pattern is this one here, and you might notice this number pattern here, 2, 4, 6, 8. It's the doubling pattern, or each successive term is multiplied by 2. That 2 is called a common ratio. Common ratio could be divided by to get the successive terms, so it means the pattern would be going down, increasingly smaller, or it could be multiplied by this one where it's increasingly larger. But we're timesing, okay? We're timesing each of the successive terms, timesing or dividing each of the terms to get the next term. The previous one was adding or subtracting to get the next term in the series. Okay, now here's a different one. This is one looking for an increasing or decreasing difference. Okay, increasing or decreasing difference. Now, let's look at this one, this pattern here, 1, 3, 6, 10, 15. You can see the difference between the 3 and the 1 is 2. The difference between the 6 and the 3 is 3. The difference between the 10 and the 6 is 4. So you can see that the difference is increasing by 1 each time. Okay, that's a special type of pattern which you don't see that often. This next type of pattern, it's one that could involve 2 patterns at once. Now, if you look at every odd term here, 2, 4, 6, it's going up by increasing by 2. Okay, look at the even numbered terms, you've got 8, 7, 6, and they're decreasing by 1. So that's a pattern where you've got 2 things happening at once. Again, that's a very special one, and you won't see it that often. The last one. Well, last one that we're going to look at, there are some special types of patterns that follow. There are square numbers, there are prime numbers, and there are Fibonacci numbers, and lots of other different patterns which have formed special ones. Look at this one here. It's 1, 8, 27, 64, 125. This is actually the pattern of the cube numbers. Okay, 1 cubed is 1. 2 cubed, which is 2 times 2 times 2, which is 8. 27 is 3 cubed, 3 times 3 times 3. 64 is 4 cubed, 4 times 4 times 4, and so on. Okay, so this pattern here would be the cube numbers. Let's look at a couple of examples and let's see if we can write out the next 3 terms in each of these patterns here. So it says in example 1, find the next 3 terms in these number patterns which have a common difference. So these are actually helping us out, telling us we've got a common difference. So let's look at our common difference here. 6 going to 18, 18 to 30, 30 to 42. You can see that our common difference is 12. So we're adding 12 each time. So we add 12 to 42, we'll get 54. If we add 12 to 54, we will get 66. And if we add 12 to 66, we will get 78. Right. Common difference here, well, it's a going down one, so we're looking to see what we're subtracting. So 99 minus 92 is 7. We're minusing 7. 92 minus 85 is minus 7 again. And just to confirm, 85 minus 78 is minus 7. So we're going down by 7s. So our last three terms, 78 minus 7 is 71. 71 minus 7 is going to be 64. And 64 take away 7 is going to be 57. Right, example 2. Find the next three terms for the following number patterns that have a common ratio. Now remember, a common ratio is where we're timesing or dividing. Common difference is plusing or minusing. So how do we get from 2 to 6? Well, we can times that by 3. How do we get from 6 to 18? We can times that by 3. How do we get from 18 to 54? We can times that by 3 as well. So we're going to times by 3. And that is going to generate some big numbers. So I'm going to get my calculator ready. Here it is, calculator. So 54 times 3 is going to be 162. Right. Times that by 3, and we'll get 486. And if we times that by 3, we will get 1,458. 1458. Alright, our last one. 256 down to 128, down to 64, down to 32. If I do 64 divided by what? Well, 32 is half of 64, so we're dividing by 2. 64 is half of 28, so it's dividing by 2 there, or dividing by 2 there. Now, you could always say, instead of dividing by 2, we're timesing by half. Timesing by half. Both will work. Okay? We get half of 256, it's 128. Half of 64 is 32. Half of 32 is 16. Half of 16 is 8. And half of 8 is 4. And there's our final pattern.